Let us now study about ohmic devices and non-ohmic devices. Now, as the name tells us, ohmic devices or ohmic conductors are those devices which obey Ohm's law. Now, Ohm's law was written in the form V is equal to I into R. Now here, this R is a constant. Therefore, if we plot a graph of V versus I, it will be a straight line because this is of the form y is equal to mx plus c. It's of this form only. We can rewrite this as saying I is equal to V into 1 by R. This is what we write. This is of this form only, where the slope from here, which is m, is given as 1 by R. The reason that you want to write it in this form, not in this form, is because whenever a graph is plotted, keep in mind that along the x-axis and y-axis we plot two parameters. Along x-axis, it is always the independent variable, because sometimes some people will tell interchange also, but by convention, any parameter which is independent, if you have a function, if you have something, a function of say a y is a function of x, it implies y depends on x. So x becomes the independent variable and y is the dependent variable. So whenever any function is plotted, then always the parameter which is independent will be on the x-axis and the parameter which is dependent will be on the y-axis. From Ohm's law, we know that the current is directly proportional to the voltage drop, which means voltage is the independent variable and current is the dependent variable. So for that reason, we write this as I is equal to V into 1 by R. As seen earlier, this is the form y is equal to mx plus c. Here c is 0, hence the graph will pass the origin, and m, which is called a slope here is equal to 1 by R. So any device or any conductor where a graph of current versus voltage is a straight line, then that conductor or the device is called as a ohmic device. Any deviation from this will be called as a non-ohmic device, a non-ohmic conductor. There are many examples of non-ohmic devices around us, but from class 12 point of view, in textbook there are two important devices given. One is called as diode, other is again a material called as gallium arsenide. Even this is used in many cases. Even this is used as LEDs also. This is some kind of a device. Similarly, we can plot a graph of I versus V from many such alloys also, but I'm just taking two devices because this is what is mentioned in textbook. But the point here is to understand that any deviation from a strict straight line or any deviation from linear behavior will be a non-ohmic device. Anything, even a form like this, it's straight line till here and then it curves like this, even this is a non-linear device, which means we can have infinite such behaviors or such graphs. But the two what is given in textbook is one for diode, where the behavior is like this. Now why the graph behaves like this, or why is the relationship between current and voltage like this, becomes clear when we take up diodes. And just by heart this, that for a graph for gallium arsenide, the graph looks like this. There is no need to understand as to why it behaves in this pattern. Just learn from exam point of view that the behavior for a device like this would be something of this kind. So these are examples of non-ohmic devices.